I think there've been a lot of talks today about machine learning in production, and a lot of the talks have covered, for example, different technologies as well as different, you know, uh, uh, individual best practices and experiences of people who have had to put machine learning into production in various contexts. Like Bharat shared what it means to do machine learning in the drug discovery space and how uniquely interesting and challenging it is. And similarly, Shankar spoke about how it is uniquely interesting and challenging in the problems they're solving, which are diagnostics and such on telemetry data or fast streaming behavioral observation data. So what I'm going to talk about today is this just overall MLOps space, and the MLOps space is relatively new, and how it has evolved in the last couple of years. What are the big things that are going on right now, and things like that. And I'm going to do a little bit of a deep dive into two areas. One of them is as it relates to cloud, and the other one is as it relates to behavior and health of machine learning models and their diagnostics. And both of those are motivated by the fact that they're fairly front and center right now, in the land of MLOps. So what are we going to talk about in this talk today? We'll first talk about what is MLOps and what are the different areas that it encompasses. What are these areas? How have they evolved in the last couple of years? What's happened? What are coming down the horizon? Stuff like that. And then do a bit more detail into two topics in MLOps, one being notably cloud and the other one being notably drift. And then we'll talk a bit about just the future of MLOps and what are some of the areas that are not really quite well matured yet, but are certainly becoming more and more critical every day, and what are the challenges there as well as the tooling that is coming up in those areas. So that's what we'll cover in the talk today. So, as a context, there are a lot of AI tools out there, as most of you know. And, this is more of an insight as to these are some of the AI tools that are available from the three major cloud vendors. And, some of these are from GCP, some are from Amazon, and some are from Azure. But the point is that there are quite a lot of them. And so there's no shortage of, ability to do things in machine learning. And there are, no shortage of tools to do that. And this is just the clouds, but if you add in other things like open source tools like TensorFlow, commercial tools like H2O or Data Robot, or other kind of best practices kind of tooling that is very relevant to MLOps like Kubernetes, so all of them, then the sheer number of things that are going on, kind of grows very, very dramatically. However, at the same time, there is a fairly small amount of adoption out there in terms of people actually being able to generate revenue from machine learning. This is a chart. It's about a few months old, but the idea is still representative, which is that in many classic enterprise kind of arenas, the number of machine learning pipelines that are in production is relatively low, and the largest one is of course in our very own IT industry where we use machine learning. Though in that area it's quite prevalent, but when you go out to things that are still very much enterprise but are less kind of enterprise as a product, then you find that the number of deployments tends to be very low. And there are fairly many reasons for this, but one of them is the fact that the flow is very complex and multifaceted, and that the tools are at different levels, and most of the tools handle some fraction of the workflow, and multiple tools collaborate. So MLOps is definitely a part of this challenge. And one of the things that makes MLOps challenging is because not just that you need tools for things, but you kind of need the tools to interoperate, and you also need a certain level of sort of practices and ways to do things that, as you've probably seen in some of the talks earlier, tend to be fairly industry and problem specific. And so part of the reason why a new company finds it hard to put ML into production is because most of the work that has gone up to date is largely been done by other companies that have solved the problem in ways that are unique to them. However, as more and more people put machine learning into production, there are themes and best practices emerging, and those are the themes that are then in turn sort of fueling the ability for other people to do it relatively quickly. And some of those themes are what we would discuss today. So a typical flow, goes through something like, a use case definition, data prep, modeling, training, deploying, integrating, monitoring, and optimizing, and then further iterating. So generally speaking, there have been trends in the last decade of things like the democratization of AI, or the kind of the automation of machine learning, that have made the first 3 or 4 stages of this life cycle more accessible to more people. So particularly, like for example, with the case of automated machine learning, as as is available in products now like Data Robot, or many of the cloud vendors and such, it is now possible for a data scientist to use the automated machine learning to kind of bootstrap and get a decent model that then they can spend more of their time, perfecting, and use their skills for perfection rather than having to create everything from scratch. So similarly, so if you look at this life cycle, I would say that, the training area particularly, and the development area is much, much more mature. And where the machine learning ops stuff comes in is really around, really around like testing, deploying, connecting, and then improving and optimizing, which includes understanding whether it's actually working in production. So those are some of the areas that MLOps kind of focuses on. So MLOps, the term, is basically is only been really around for about 2 years. So now keep in mind, production ML has been around a lot longer than that, of course. So if you look at companies like LinkedIn or Google, they've been doing production ML for many years now, I would say as much as a decade or even longer. And they have developed practices that are, that they have talked about in some ways. Now, there are a couple of, big reasons why some of those practices are not, they don't jump over immediately into the average enterprise. And by the average enterprise, I mean everything from, a big bank or some large, 100 million or billion-dollar company that has many, many products, but they are not a cloud and they don't build all their tools in-house, and they've bought, databases from people like Oracle and stuff like that. So one of the sort of the challenges has been, and to some extent continues to be, is that the the practices that have been developed sort of in a hard-won way inside big companies like Google don't automatically jump out and become usable in big companies like a bank. And there's a whole bunch of reasons for that. One of them is that companies like Google operate at a level of scale that is really not done by anybody else outside of those. And so their machine learning problems in many respects are related to that scale. And when you're talking about somebody who's got 1,000 models in production and they've got all sorts of MLOps problems related to that, how they solve those problems is not necessarily going to help the guy who's trying to get his first model in. There are also other reasons, like sometimes the large companies, they tend to have very custom tooling that they've developed over years. And so in some ways, their people have learned how to do ops in the context of those tools. Whereas the companies outside of the large web scale corporations, sometimes they bought their tools from other vendors. And so they have basically an entirely different stack. And while the idea may translate, sometimes the code actually doesn't. So even though production ML has been done for many years, I think the first MLOps platform for enterprises was developed in about 2018. And this is one of the ones that I worked on. It was from the company, the previous company I founded called ParallelM. Now, what we kind of put together with respect to MLOps for enterprises, which is now, by the way, the Data Robot product, is essentially recognizing that in an enterprise world, there are, previous experiences of being successful at complex software, particularly if you look at a database, like an industrial strength database, like an Oracle, of the world. And if you speak specifically about Oracle, for example, is an extraordinarily complex and powerful piece of software. However, databases of that level of complexity are in use in literally every company in the world now. And so their complexity did not stop them from being used. But now the question becomes, how did they get used? And then if you look a little bit more into it, you'll realize that there's an entire industry built up on making those databases usable. There's a job called a DBA. You train to be a DBA. You get certified to be a DBA. People hire you to be a DBA. And so people have realized that in order to make a very complex piece of software like a database ubiquitous and used by everybody, you really have to handle its ops. And you have to have people who are specialized in not just ops in general, but ops of the database. So there's also like established practices for and tooling for software lifecycle, how to roll out software in production, how to do DevOps, and things like that. And what was lacking in the enterprise world was that kind of an operative element for machine learning. And so what I took here from here is this paragraph that I took here is from the original Wikipedia entry that we wrote for MLOps. And it was intentionally written as MLOps is a compound of machine learning and operations. And it's a practice of collaboration, communication, and managing production ML, similar to like a DevOps or a DataOps approach. And it has many, many, elements to that. And so this is a field that is going to continue to grow. And some of the elements are, even 2 years later, quite reasonably well established, and some of them are just kind of coming on the horizon. So, and then there's this notion of an ML lifecycle practice, which is kind of recognizing that you don't just put an ML into production, you kind of take care of it every single day that it's in production. And then it kind of grows and evolves, much like any other complex piece of software or complex service. So that's sort of how it initially kind of came about and where it drew the parallels. And these parallels are actually interesting from a practical perspective, because by looking at these parallels, you can start to see what is different about ML and what is not different about ML. And so, for example, using code for GitHub, ML code for GitHub is a case where it is sufficiently similar that you really should do that. And then when you have other things like when, diagnostics and such, it is sufficiently different that you really have to do something new. So if you look very quickly at sort of the nature of MLOps evolution just in the last 2 years, from the point when the term first appeared to where we are now. So this was a simple description of what MLOps, the pieces looked like when we first looked at them in 2018 on the context of an enterprise. And there are, by the way, elements that were already in practice in large web scale companies that aren't even included in this graph because they were not yet relevant to enterprise, but they were extremely relevant to people who are in web scale companies, and enterprises will eventually get to the point when they will need that relevance too. But some of the initial areas that were looked at for enterprise were things like, how do I even get a model into production? I have it, it's been trained, my data scientist is very happy with the results of it, but now how do I even get it deployed and used? How do I run the thing? If I needed to run a training job, how do I run it? How do I know if it's working? How do I know if it's impacting my business? And how do I, basically make sure that I follow any rules that are important to it? And so one of the things is that if you look at all of these areas, they are not all equal when it comes to their importance as well as their urgency. And so if you look at from 2018 to 2020, 2018, where most of this stuff in the enterprise was very, very nascent, to 2020, where some of them are and some of them are not. So if you look at 2020 and you look at like this particular bucket here that I'm moving with my mouse, there are well-established methods for machine learning deployment now. So there are, for example, deployment tools. There are deployment tools for models that you can build in open source. There are essentially, you can do batch deployments, REST deployments, stream deployments with relative ease. There are many patterns out there right now where you can use to follow and create a deployment architecture. Model serving, building a model serving solution that is production grade is relatively easy. Now, I think the difference is that, for companies that are doing their very first model deployment, then, there are definitely fairly straightforward solutions that can be used. For companies that are doing their second, their third, their 10th, they are still finding issues in the serving mechanisms that are out there today that are mainstream. And as a result, there are startups that are basically being founded on simply doing better serving for the people who have discovered that now at least they know how to serve. Previously, the problem was they didn't even know how to serve. And now they know how to serve, and now they're starting to form opinions on what they want. And then there are now startups that are emerging, that are trying to meet the needs and fill in the gaps of the major serving tools. So that's so I would say, deployment and serving is something that has really come a fairly long way, in the last 2 years. Now, reproducibility is the same way. I think reproducibility, there are lots of tools out there right now. So, most of them use some kind of source control system or some kind of a database. There are databases dedicated to this, like ModelDB. There are companies that are built around those databases, like Verta AI and so forth. And there are quite a few open source tools out there as well, like MLeap, that will help you with reproducibility. Similarly, the land of containerization and orchestration has come along a very long way. So for example, in an Amazon cloud, you can easily, bring in a Docker container that contains your model, and you can configure Amazon to accept that container and orchestrate it, launch the training, launch the predictions, connect it to a serving mechanism and so forth. And those kinds of things are starting to become, fairly reasonably well established to the point that even a small organization can actually do some of these things. Areas that are, I would say, less established and more emerging are the areas of governance, monitoring. So if you look at like the model governance part of this, or the ML health, or the business impact, these are the areas that are still fairly nascent. And part of the reason why they're nascent is because, you do need to have something in production before you start worrying about this. So if my biggest problem is that I have a data scientist with a model and I don't know how to connect it to my app, I'm probably not that worried about governance or monitoring. However, there are things that are happening here where there are laws coming out in the horizon that are becoming, sort of increasingly applied. So, for example, the first laws in this space of governance came out about almost a year and a half ago, maybe 2 years ago. And one of the things that kind of we've learned, the people who practice these things learned, is that there are laws, and then when the laws first come out, people are as understandably confused. And then there is what's called sort of case law, right? Or case evidence. And so what happens is that something is going to happen, and that something is going to result in a lawsuit. And in an attempt to resolve the lawsuit, somebody will, try to interpret the law. And that will generate case law, and that will generate like hard facts that then companies can look at and say, okay, now at least I know what I need to do. Because sometimes the laws are just simply hard to understand, and I could go, haywire and build everything, or I could do nothing, and both seem, you could argue for both in the context of the law. So case law is not yet fully immersed in these areas. The laws have been around for a while. The people who practice in this space expect case law in the next year, and then that will mean that case law will result in then some more hard and fast stuff that can then actually be converted into code. So monitoring and health diagnostics, I'll talk about in a little bit, because it's actually suddenly become very front and center. And then the life cycle is something that is basically, as people build their first models and then start, trying to iterate, it's becoming more of a factor. So that's kind of a little bit about sort of where MLOps has been in the last 2 years, and what are the areas where, there are established tools that you can learn and practice, and then areas which are still sufficiently nascent that they kind of, you apply them in the context of their own, the industry that you're in. So now I'm going to go into two different MLOps topics and in a little bit of depth. And the two MLOps topics that I'm going to cover are essentially, cloud context. I'll give you a little bit of cloud context of how MLOps applies in AWS. Then I'm going to talk a little bit about Drift. So if you look at MLOps in the context of AWS, say that you are using AWS for doing production machine learning or deep learning. What I'm going to say applies to both. Then here are some of the things that you can kind of think about. So first of all, from a point of view of available tools, is kind of a stack of tools. And depending on what you're building, you will always have the bottom pieces, and you may or may not have the top pieces. At the bottom piece, you always have the infrastructure. So you need to always worry about your instances, your authentication, where you're keeping your data, how you're billing those, how you are managing them, things like that. Labeling is something that may or may not be part of your life cycle, depends on your environment. If your labeling is part of the life cycle, then labeling tools is something you need to fit into it. Data prep and visualization, usually at least the data prep part becomes important. Visualization part kind of depends on your use case. Modeling and deployment, this is always a critical part of any ML lifecycle. So no matter what else you've got, you've probably got this. And then some of the newer things that you want to kind of keep in mind is that there are these notions of marketplaces and service APIs. So a marketplace, the basic idea is that, people sell models and people buy models. And so what are you buying? When you sell a model or buy a model, you're effectively buying a Docker container. And that Docker container contains a model and the inference code. So one of the things that has kind of made the production ML space so much more interesting in the last few years is the presence of these marketplaces. So now you may not necessarily need to train a model. You can actually buy yourself a container, which has a trained model or a model you can retrain, and it comes with a companion container, or it's the same container that then can do the inference for it. So this brings up a really nice element where you can sort of like buy and trade, machine learning IP as you might buy and trade goods. Then you have service APIs. So service APIs are pre-built AIs for various functions. So if you think about a function that is, say, fairly common, very important, very valuable, but not unique to you, then a service API is a really good way to push the MLOps responsibility completely onto the cloud vendor. So for example, if I were to connect with Amazon and use their chatbot API and configure myself a chatbot for something, then the MLOps aspect of that is something that by implication, the API is going to take care of. So I can use it and I can benefit from it, but I don't have to actually maintain it or take care of it. Now, the trade-off is, of course, that you can only do this for things that are generic. So examples of good generic things are if I wanted to read documents like OCR documents, if I wanted to recognize famous people in photographs or have a decent, configurable chatbot conversation or something like that, then service APIs are amazing. So depending on, so the first thing in the MLOps context in terms of an Amazon kind of world is to kind of recognize that there are all these stack levels and you are using some fraction of them. So now, if once you have all of that, then here's a simple example of a life cycle, and I'll give you guys a quick demo of this life cycle in action. You can have a data set, you can put in pipelines in Amazon to do prep and transform. You can, then put the data set into one of the stores. You can use either a built-in set of models inside the training tools, and then those built-in set of models can either be configured or they could be brought in by your own code, or they could be bought from a marketplace. Once you have something trained and you've generated some kind of an artifact, then you can do the deployment part of that artifact by essentially invoking a deployment tool that creates an endpoint. So this is, by the way, a way to do a simple REST deployment. You could do batch deployments, in a slightly different way, but kind of the same level of config, if you will. Then you can basically connect it to the rest of your application in a variety of ways, like attaching a Lambda or a serverless function, and then connecting it to external or internal applications. So this is a simple flow that you could follow. And by the way, while I've listed this flow in the context of Amazon, this flow is not unique to Amazon. Exactly the same flow can be done, for example, in Google, cloud platform, where it would be Google Store here. It would be the Google AI, platform here. It could be, essentially their own endpoints. It could be their cloud functions. And so the structure remains the same. And within the cloud, you can kind of build together these pieces. And so then the MLOps challenge really kind of becomes, now how do you sort of take care of this and manage it, and then each cloud vendor typically has also a unique approach to things like logs and billing and diagnostics and so forth. And so that's sort of what the MLOps challenge inside the cloud kind of looks like. So what I'll do is I'm going to show you guys a very quick demo of how this looks inside the context of where I'm looking for my slide. Sorry. How this looks in the context of actually a configuration of an Amazon system. And this is just about 1 minute, and you can see very, very quickly. Obviously, it takes a little longer.
First step in creating
you can see how it's actually configured inside an Amazon context.
First step in creating an end-to-end AI in AWS is to bring your data into folders in S3. Here we have images of cats and dogs uploaded to S3, followed by creating a SageMaker training job using a deep neural network called ResNet, short for Residual Neural Network. After the training completes, a SageMaker endpoint is launched, which is then connected with an AWS Lambda. This Lambda is an interface between the outside world to the internal AWS endpoint. You can test this Lambda to make sure it triggers the endpoint and provides a prediction. This Lambda is connected to an API gateway, which is accessible via a REST endpoint. You can trigger this microservice created in AWS using any external application. An example of invocation using Postman is demonstrated here.
So that just is kind of a little bit of a whirlwind tour of how you can, create a life cycle inside the context of a cloud. So it was intentionally done a little bit fast because we want to kind of just do a bit of an overview in this talk. But certainly it is possible to do that and do it in a fairly different numbers of ways by connecting together different tools like this. The next thing I wanted to kind of talk to you guys about a little bit different is this notion of health and drift. And part of the reason I want to talk about it is because it is both an emerging area of MLOps, but it's also an area that has suddenly become very relevant due to COVID-19. So first of all, what is drift and why did COVID-19 sort of make everybody aware that there's drift? So drift is basically what happens when your machine learning model was trained in a context that is not different from what it sees in the real world. So those of you who attended Bharat's talk right before this one, he mentioned that there are some very unique representations of drift that occur in the drug discovery practice that are not like anything that is seen in any other context. However, drift prior to COVID, drift was a problem that was hard to see when people, unless you put, something actually into production. But however, the presence of COVID-19 actually made drift something that almost anybody who was doing any kind of production ML suddenly saw. And the reason was because COVID-19 and the consequent, shelter at home practices and the changes to the economy and all of the things that happened pretty much just broke so many different machine learning models. So any machine learning model, for example, that was used for product recommendations, for supply chain forecasting, anything that tried to predict what a customer would do in any respect, pretty much broke. Because the way that people are behaving right now, the way they're spending money, what products are being bought, where are they being sent, food is no longer being sent to restaurants, it's now being sent to homes and stuff like that. And so pretty much that is a case of massive drift where the models were trained from years of past practices and were suddenly in an environment where none of those practices were relevant. And so if you go and Google, for example, now you will find a fair number of articles about drift that are basically, most of them are motivated by the examples that were provided or are encountered, sadly, in the context of COVID-19. So drift is an important area of MLOps, and it really has to do with, can I tell how well my machine learning model is doing? And when my machine learning model goes into production, is there anything that, how is it going to behave differently? And if it behaves differently, how do I know? So there are various kinds of drift. There's at the topmost level, there's a notion of concept drift and there's a notion of data drift. Now, concept drift is more tricky, and what is happening is that concept drift is what happens when your data hasn't really changed, but what your data implies has changed. And so something like an example, which is completely artificial, but we'll hopefully get the point, is, say that my historical data tells, tells a company that if I am buying eggs and I'm buying butter, I am also going to buy flour because I'm making cakes, right? And so over time, the machine learning model will, learn to recommend flour when I buy eggs and butter. On the other hand, for some reason, if I've decided I'm not going to make cake, but I am going to make omelets with butter for some strange reason, then suddenly, I'm still buying eggs and, butter, but the mapping of that to flour is no longer accurate. So that's something like a concept drift where everything is still fine, but the user's behavior has changed in a way that the linkage no longer works. That's much more complicated, and that is really not necessarily what's happening now. But there's a much simpler concept that you catch into and run into long before you hit concept drift, and that is data drift. Data drift is simply where the behavior changes, and sometimes it just changes, and it changes, but your training data has already sort of factored it in. And there are some cases where it changes in ways that are very different from the way that you've trained it. And so these are typically captured by, distributions in data. And this is an example of like this, the training data might have looked like this. Then over time, my production data may have gone in all sorts of ways. And so you need to basically be able to recognize this drift, at the same time also create test suites that essentially mimic this drift so that you can test it. There are many different ways that you can detect these kinds of drift. And if you're interested in more of a theoretical overview of these drift types, let us know, and we can maybe, try to help you. Some of these are covered in the classes that Bill mentioned. But there are things like, first of all, you want to try to understand the distribution shift. You can monitor some basic statistics. You can apply some more advanced drift techniques and things like that. And all of these techniques that I mentioned here are basically for individual features. Now, there are other more subtle things where possibly an individual feature may not have drifted much. Maybe a second individual feature may not have also drifted much, but when you combine them, relatively, they have drifted together in such a way that the combination is now way off from the combination that the training system saw or the prediction system saw. So there are relational drifts where many multiple variables, either two or multidimensional drifts, can occur in such a way that watching a single variable will not tell you, but somehow attaching to all of them is going to tell you. So these are some of the areas where people are still kind of struggling with trying to understand the notions of drift. Now, other areas that are emerging in the future, model governance is a big one. As I mentioned earlier, there are some areas that are heavily regulated. Some are just seeing regulations. These are some of the regulations that have gone into effect in the last year that have not yet had established case law. And other areas there is some case law and things like that. And so this is an area that companies are starting to see as a concern. Another area that really receives very little discussion, but we're starting to see it, is the security aspect. So there are companies like that, for example, in the financial trading spaces that actually have security teams for their models. And and this is another one of those where so similarly as the events of COVID-19 kind of put a focus on drift and made drift real for a lot of people, unfortunately, as models get put into production, security issues usually become important when something happens. So as a summary, I think MLOps has gone a long way in the last 2 years. There are tens, maybe even, I don't know if there are 100, but there are definitely multiple tens of startups. Deployment was a big challenge about 2 years ago. Now, deployment is much, much more established. The other things are starting to show effect. Job roles are emerging. You can find jobs now for MLOps engineer, full stack data scientist, applied ML engineer, so forth. And then if you look at the people who are the most advanced in their deployments and who have more models in production, they worry about validation, security, adaptability, and scale. So hopefully that was helpful. I can now take a few questions. So first question is, in your opinion, what are the leading tools and vendors for the categories you define in MLOps? It's a very good question. I think it's too early right now for leading tools and vendors. There are quite a few tools out there, but I don't know that any of them are leading. The one thing I would say is that I think Kubernetes is becoming a very powerful, uh, approach that a lot of people are finding very helpful. So that's not really an MLOps tool, but it does underlie a lot of the MLOps, needs. And so of all the things that I feel are, not, which one is leading, I would say Kubernetes seems like it's becoming a de facto. So the next question is, what kind of drift has COVID caused? So the kind of things that I mentioned, which is consumer buying patterns have changed drastically, which means product recommendations, projecting inventory, projecting how to do supply chain, where to route things to, all of that has changed. So, one of the biggest changes, for example, is that prior to COVID-19, the vast majority of the US food supply was intended for restaurants. And so companies that manage that supply chain pretty much was optimized to shove a lot of this stuff into restaurants. And then immediately what happened within like a few weeks is that the restaurant shut down. And that's why we had a situation where people could not get eggs, but at the same time, farmers were destroying eggs because they couldn't figure out how to get it to the people who needed them. So there's been stuff like that. So anything in the supply chain or behavioral patterns has been impacted. Finance has been impacted too. Next question from Kumar. Are there services or tools that offer A/B/N testing? Yes. There are quite a few tools that offer A/B testing. I think, particularly, I think if you kind of look at most of the MLOps tools, I expect Selden does, and as well as I think DataRobot does, H2O does, most of them do. A/B testing is pretty standard now in the land of MLOps tools. Next question, in your opinion, will there be an AI ops concept which will be developed? So AI ops, by the way, is a term right now, and the term means using AI to improve ops. Whether you agree with what that term means, whether it should mean that or not, that's what it currently means. And so AI ops is a term that's used by people when they are trying to, for example, if they want to figure out how to manage their machines, they want to know if a machine is down, they want to know if there's been a security hack on an operating system, and they're using ML for that. They call that AI ops. So depends on what you mean. That's what the term means today. So if you mean something different and you're asking whether a different concept would be developed, please respond and tell me what the concept is, and then I might have a better idea. So next question is from Ja. To work in the MLOps field, is it more important to have a good background in systems or ML? It's a very good question. I would say that, a good systems knowledge is important, but if you're a systems person, you should really understand the unique ways in which ML can behave, fail, needs to be tested, and so forth. Honestly, I think you could go from either direction. It's more of what I typically look for is a willingness to learn. So if you're open-minded that there are unique things in the other field, then I think you can go a long way. I've seen people do it both ways and be successful. Next question is by Kevin. In what level can consumers and users engage in early stage MLOps projects through their mobile devices and computers? That's actually a very interesting question. So computers, I would say that, there are a number of MLOps tools out there that are open source. Selden has an open source core, as does ModelDB, I believe, has an open source core. So if you're interested in engaging, utilizing the open source is a very good way to do it. Whether or not those cores are amenable to mobile devices, usually